Hello everyone, welcome to LeetCode walkthrough series. Today we are going to solve move zeros problem. The problem says, given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. So they've given an input array called nums where it has non-zeros and zero values. We need to make sure all zeros come at the end of the array and all non-zeros at the start of the array without disrupting their order. So the end result would look something like this. So we have all non-zeros at the start by keeping their order intact, and then all zeros at the end. Now, how we would solve this is there are two approaches. One is brute force method, which says iterate over the entire array and take all the non-zero values and store it in a new array list. Okay, and the remaining elements append all the zeros at the end in this new list. So this approach takes two passes. First pass is to find out all non-zero elements, and second pass is to copy those non-zero elements into a new array list and append all zeros at the end. So there is also a better way to solve this by taking two pointers approach. Let's say we'll call them left and right pointers. To better show this approach, I will use the whiteboard here. So we have the array here, and two pointers will start from the start index, left and right. Okay, the right pointer is responsible to traverse entire array and find out all non-zero elements and swap it to the value of left pointer. So this is done because all non-zeros come at the start, and left pointer is responsible for having all the non-zeros at the start. Let me show you. So what R does is, let me write it down here first, the algorithm. So for right pointer, R, let's say right in okay. Now if right pointer nums of right, the value of right pointer encounters any non-zero value, we swap it with nums of left. Okay, so here for every non-zero encounters, it swaps it with left pointer, and then we will increment. I forgot that. Yeah. Okay. We'll increment the left pointer. Okay. Now let me do the dry run here. So first value is the non-zero value. It swaps it with L, and it stays the same. Nothing happens, and then R moves forward, and left also moves forward because of this condition. So we have one here, which is non-zero. It swaps it with the left pointer, and then R moves forward, left moves forward, and then R also moves forward. Sorry. Okay. Now here 2 is the non-zero value. It swaps it with L, which is the same value, and after swapping, left moves forward, and R also moves forward here. Okay. Now R is 0. Now the swap doesn't happen, the condition failed, and it moves on to the next value. So here we have non-zero value. It swaps it with the current left pointer, and okay. So after swapping, the value becomes 1 and 0. So as you can see, the zeros will always get pushed at the end, at the last index. Now moving on, here R moves ahead. Now we have a 0, nothing happens, and again R moves ahead. We have a non-zero here. So yeah, I forgot to update this L value here. After swapping, L always updates to one value. Now R is at the non-zero position. We swap it with the L pointer. Okay, so this becomes 1 and this becomes 0. Okay, let's move on. R is 0 and nothing happens. Now okay, L is updated here. Okay, okay, now R that's previously after swapping it happens, the updation happens here. Now R is at the R comes to non-zero value, again swapping happens. Now the values become 1 here and at the end 0 here. So at the end we will have all non-zeros at the start having their order intact, and all zeros at the end. So hence the problem is solved. So let me copy this algorithm for easier understanding. Oh, sorry. Okay. Okay, now okay, now let me code this solution here. First let me initialize the left pointer to 0, and then we take the for loop for right pointer to iterate throughout the input array for writing range. Okay, now for every value of right, I mean non-zero value of nums, I mean the value of right which is non-zero, what it does is it swaps with the left pointer. So this is the swapping logic, and then updates the left pointer. And yeah, this is all about it. It's this, once the loop ends, we will have all arrays at the all zeros at the end of the index. So let me run this. Okay, solution works, and I'll submit it. Okay, so the time complexity of this problem is the solution is successful. Yeah, the time complexity of this problem is since the both pointers moves throughout the array at least in the worst case n number of times for all the elements, L and R both moves towards till the end. At least one of the pointer moves till the end, so it is order of n. And space complexity, since we are doing it in place, it is order of 1, so there is no extra space needed for this operation. So that's all about it. Thanks for watching.